Hey guys. Alright, so I know I didn't get these posted till today, but I am going to give you a heads up that I'm going to challenge you in today's lesson. Okay? You're really going to be challenged. You're going to really be challenged to put forth the extra effort in the two examples you're supposed to do for your warm-up. Okay? I'm not expecting them to be right, but I am expecting you to get somewhere with them and not just come back with a blank paper. Alright, so let's start with this one. We got example number 1. Find the equation for the parabola fitting the given information. I will tell you that the first one is a parabola, the second example is an ellipse, the third example is a circle, and the fourth example is a hyperbola. You are going to have to do the circle and the hyperbola. I do think that based on the information that I'm giving you, I do think that personally I feel that the parabola is probably the hardest one, okay? So, we're going to take the information we know, alright? So the information we know, let me go back and actually let me pull up my information here. Okay? So, the information we know is that the directrix is going to tell us if the graph is going to open up or down or left or right. Okay? Because if you remember, this is going to be a horizontal line through the point 0, -1 on a graph. Okay? So, with that being said, that tells me that my graph is opening up or down. Because if you remember, the directrix is always going to, if it's a horizontal line, it means the graph opens up or down. If the directrix is a vertical line, then that means that the graph is going to open left or right. Because if you remember, it looks like this. Okay, it's either going to look like that, or it would look like this. That's if the directrix is a horizontal line. If it's a vertical line, however, like this, then my graph would look like this, or it would look like this. One of those two. Okay? So, this tells me that my graph is going to open up or down, which means that my equation is going to be of the form y equals a times x minus h squared plus k. I know this based on the directrix. Okay? What else do we know? Okay, well, I know that the foci, alright, we're given two different options. If it opens down, up, we're given one set of options. If it opens down, we're given the other set. So I know that the foci, if it opens up, is going to be h, comma, k plus c. And if it opens down, so I'm going to just put an up arrow here. If it opens down, then it's going to be h, comma, k minus c. Okay? So with that given, I know the value of h now. H is going to be 2. Okay? Now, what else do we know? Well, we know that the directrix, okay, if the directrix opens up, it's y equals k plus c. And if it opens down, it's y equals k minus c. Oh, I actually did that backwards. This one is opened down. This one is opened up. Okay? So, let's take the information we know then. Alright? So we know if it opens up, okay, that it's going to be k plus c. And I know that k plus c has to equal 1 for the foci. Alright? I also know that if it opens up, that k minus c, okay, which is my directrix, is going to equal -1 because of this. Alright? So I have a simple little system of equations here. I can add these together. Since these are opposite, these will cancel. Gives me 2k equals 1 and -1 is 0. Divide by 2. And I get that k equals 0. Alright? If I try the other way, so it opens down. So it's k minus c equals 1, because that's my foci. My directrix is k plus c equals negative 1. Same thing, these are going to cancel. This is 2k equals, these will cancel and give me 0, divide by 2, and I get that k is 0. So it doesn't matter which way it opens, up or down, it's going to give me my k value is then going to be 0. Alright? So now I have a vertex at 2, 0. This is an important piece of information for my formula, because my formula has to be here, which means I have h and I have k. The only thing left I have to find now is going to be a. Okay? Now if you remember with a, I'm going to erase a couple things here, give myself some space to just jot down a few things. I know that the absolute value of a is 1 over 4 times c. Okay? So now, we're going to go back. This is how we found k, and we're going to actually use this to find c now. Alright? Let me actually make this a little bigger, and I'm just going to erase it, and I'll rewrite the whole thing. So we have k plus c equals 1, and we had k minus c equals negative 1. That's for up. The down is k minus c equals 1 and k plus c equals negative 1. So if I solve for c now, because that's what I'm looking for to give me a, if I solve for c, I need to get c by itself, so I'm going to change this. I'm going to distribute a negative 1. These are going to cancel. This is going to give me 2c equals 2. Divide by 2, and I get c equals 1. If it's gonna go down, I'm gonna do the same thing. I'm gonna multiply this top one by negative 1. These will cancel. Give me 2c equals negative 2. Divide by 2, and I get that c equals negative 1. So here's my two options. I have that either c is gonna equal 1 or c is gonna equal negative 1. Okay? So now let's look at what we already know. I know that k is 0. So 0 plus, let's take if it goes up, plus 1 is 1. That fits. K plus c, if I plug the 1 in, okay, so my foci. So this is if it's going up. For the foci, I know that k plus c equals 1. K is 0. If I say c is 1, that equals 1. So this checks. Let's check down. If it goes down, then it's going to end up working out, okay, that it would be k minus c equals 1. So this would be 0 minus negative 1 equals 1. So you get 1 equals 1. So that checks. Okay? Now let's try the directrix. For the directrix, you have that k plus c equals negative 1. Oh, sorry, this should be k minus c equals negative 1. And then you also have, alright, so that's 0 minus 1 equals negative 1, which gives you negative 1 equals negative 1, which checks. If I'm going down, however, then you have k plus c equals negative 1. That's 0 plus negative 1 equals negative 1. And that gives you negative 1 equals negative 1. Okay? Now, you notice how both the foci and the directrix, both of them could be possible. So now here is the next point. This is how you determine if A opens up or down. When I draw my parabola, is my foci below or is my foci above? Okay? If my foci is above, okay, well, let me rephrase that. My foci is always going to be above, or it's going to be inside the U, okay? So in this case, get my pencil, my foci is the green dot, okay? So if my graph is going down, then my foci would be here. So if it's opening up, it's going to be a point that's above the vertex. If it's opening down, it's going to be a point that's below the vertex. My foci, if you notice here, you have 2, 0. My foci is 2, 1, which means it's a point that's above the parabola, above the vertex. So that means my graph is going to open up. Okay? So I showed you this to show you that when you're looking for your foci and your directrix, if you try to find C this way, it's going to actually give you the same information for all of it. So that's not going to work. You have to use the fact of where the foci is located to determine which one it's going to be. So because I know my graph opens up, then I know that K is 0, and I know that C, for opening up right here, C is 1. So I'm going to say the absolute value of A equals 1 over 4 times 1, which means that A is going to equal 1/4. Okay? So now I have everything I need to know. My equation then is y equals A, 1/4, times x minus h squared plus k is 0, giving me my answer right there. Okay? Tomorrow when you guys are in here, I'll probably try to explain the parabola part a little bit better and how to determine whether it opens up or down. Okay? I might have confused you a little bit. I wanted to make sure I showed you that if you did it the way I did it originally, that it doesn't give you the information you need. So now we're going to get to the ellipse. Okay? The ellipse has a center 6, -7, and there's one thing I want to point out. If you remember when we talked about ellipse, we talked about vertices and we talked about covertices. The vertices are going to have either the x's are going to be the same or the y's are going to be the same because they are on the same line. They're either on a vertical line or a horizontal line. The covertices are going to either be on a vertical line or a horizontal line, but they're going to have the same as well. So when I look at this right off the bat, my x's are not the same, and my y's are also not the same. So this is actually going to be a covertice, one of them will be, and one of them will be an actual vertice. Okay? So, we got to remember with an ellipse, the center is HK. So that means that H is 6, K is -7. Alright? And the other thing I notice is that if you remember with the vertices, one of them is going to be H plus or minus A, sorry, the vertexes. One is going to be H plus or minus A, K, and the other one is going to be H comma K plus or minus A. Alright? So knowing that's true, if I look at the first point, my K's are going to be the same. Alright? And this is for vertices / covertices. Okay? So my K is the same here, which means I'm looking at this right here. Alright? So I have H plus or minus A, comma, -7. And I know that H is 6, so that's 6 plus or minus A is -7. Okay? Now when I look at this point here, I have the point 1, -7. Well, the only way to get from 6 to 1 is to subtract 5. So that means for this right here, I am doing 6 minus 5, -7, which gives me the 1, -7. Okay? So right here, A is going to be 5. You can tell that by this right here. So now I have that A is 5, So now let's look at the second point. We notice that the h's are the same as the vertex. So now I have 6, comma, k plus or minus a number. Okay? And actually, if you remember, I'm actually not going to use a or b right here. Let me use x. Okay? Because when I look at, just a second, I'm actually looking at the wrong page. When I look at this, I need to, the way I tell which one is A and which one is B, okay, is, and I actually need to readjust this, okay? So this is the covertices, or excuse me, this is the vertices. This one right here is where A is below X. This one is where B is below X. Okay? So then the covertices dealt with B. Okay, and B affected. So we don't know if the X is going to be A or B. We determine that based on whichever one is bigger. Okay? Because if this number here affecting the H is smaller, then that means that represents B. If the other one is smaller, then that's the one that represents B. And I'm probably going to have to go over this a little bit better with you guys tomorrow. So I know that this one, we're going to call it y, is 6, comma, k plus or minus y. And I'm going from, I also know that k is negative 7. And I have plus or minus y. And this has to equal negative 5. So negative 7 plus or minus y needs to equal negative 5. Well, the only way to go from negative 7 to 5 is if I say negative 7 plus 2, and that's going to give me negative 5. Okay, so that means that this y value then is 2. So whichever one of these is bigger is going to be your a. So that means, based on this, that a is 5 and b is 2. Now if you remember with the equation, okay, the equation is x minus h squared. So we have x minus h is 6 squared, and this is over a squared, which is 5 squared, so that's 25, minus, plus y minus k is negative 7, so that's going to be plus 7 squared, over b squared is 4 equals 1. Okay? So what we're doing here, guys, is we're really just trying to take all the information we have with the formulas. We're taking the center, the vertices, we're using that information to plug it in and to just find little pieces as we go. Okay? For example, with the vertices and the covertices, how you determine which one is the vertice and which one is the covertice is based on if A is below X or A is below Y. Okay? And I'm actually going to go over that a little bit more tomorrow. So, you guys are responsible to do the circle. I want you to try it. Give it your best shot, okay? I don't want anybody coming in with a blank paper. So here's the information for the circle. Find the equation of the circle fitting the given information. You have a center at negative 6, 10, and a radius of 1. Circles should be fairly easy. And then you have the equation for a hyperbola fitting the given information. You have that the foci is at 0 plus or minus 5. And you have the vertices are at 0 plus or minus 4. Okay? Do your best. I will go over parabola and ellipse again tomorrow, and I will also have you guys do your problems on the board. Okay? Have a great night. I hope that this didn't completely confuse you, and I will talk to you about it more tomorrow. Okay? So have a great night, and I'll see you tomorrow.